Hello, ladies and gentlemen. My name is Elise Huard. I'm from Belgium and I live and work in London for a company called Huard. When you think of it, a movie is a very parallel process. When you start filming a movie, you want the filming to take as little time as possible because time costs money. So when you have different actors playing in different settings, you're going to film those scenes at the same time. And when you have the same actors working in one, or different actors working in one setting, you'll still try and film them as much in parallel as possible. And at the same time, the composer is composing the soundtrack with as much data as he has to make it stick to the story. Then at the end, when the filming is done, everything is added together by the director who cuts it, and then maybe special effects is going on also in a parallel track. And then finally, everything comes together in a kind of map-reduced process. So any human in fact, when you think of it, any human process of any complexity happens this way, with a lot of specialized workers passing data to each other, passing results to each other, and to come to a result. And so you'd think that we as programmers would also try and reproduce this way of working in our programs. But until recently, this was not possible, since we worked mostly with single processor architectures. So there was no point in making many things working at the same time, because concurrent processes would just be time sharing the same processor. However, that has changed. In the last 10 years, we have more and more cores, more and more CPUs per machine. And so it becomes sensible to really think about writing concurrent processes. However, concurrency is quite hard because under your program there is the VM. Under the VM there is the operating system, and every one of those parts will introduce their own scheduling, and so you have no control whatsoever of how your program is going to run, how the parallel parts are going to run one next to the other. And this introduces a problem when you have shared and mutable states. When several threads access one set of data together, you have the possibility of the results being indeterministic, and that makes it really, really difficult to program well without any kind of locking mechanism. And ever since, but we've also noticed that explicitly creating locks is really difficult. You create your own problems. You can create deadlocks. When several parts are holding resources the other one needs. So yeah, that's a really difficult way to program concurrent programs. You might ask, as a script programmer, as an application programmer, should I worry about concurrency? Should I just not trust the web server to do it for me? Should I not trust the compiler to do it for me, or the framework I'm using to do it for me? And I think we should worry about this. We should think about this. As good programmers, we should know what we're playing with. So that's where I come to actors. The actor model was invented in 1973 by someone called Huard. He described it in an article. And after that, a student of his, Gul Aga, wrote a PhD on the topic, and this was basically the start, the groundwork of what we call the actor model. So what's the actor model? Well, we have no global state. or at least no explicit global state. We have actors working one next to the others, and actors can send messages asynchronously and receive messages. When an actor receives a message, it can send another message, it can have a certain behavior, or it can create another actor. And using actors means we're letting go of the global order of execution we were talking about. We're accepting the fact that we have indeterminism, and we only have control over the order of execution within our actor, or within a certain set of our program. This means effectively that we're limiting the mutable state within our actors. The actors don't share state between one another. They just send messages, immutable messages. Any mutable state is handled within the actor. The actor is the state machine. I use several code examples in my presentation, and they're all centered around the same example, which is a sleeping barber. The sleeping barber is a well-known concurrency problem. The story is as follows. You have a barber who is in his barber shop. The barber can either cut the hair of a customer, and when he has no customer, he sleeps. When a customer comes into the shop, if the barber is busy, the customer sits. If the barber is not busy, then he wakes the barber. And if all the chairs, are taken, then the customer leaves. This is a well-known concurrency problem in the sense that if you don't exercise any control, you might have two customers arriving at the same time and trying to occupy the same chair, or the barber trying to cut two people's hair at the same time. This is traditionally solved by using mutexes. I modeled this with the actor model. This is one way to model with the actor model. There are other ways to do this. So we have the actor for the barber shop and an actor for the barber. And the customers are basically just messages sent to the barber shop. However, I think the barber shop is a little bit of a boring analogy. So I prefer to add a random factor to it. This is a picture from a movie, a German movie from the 1930s, a silent movie. And it's called Mysteries of a Barber Shop. And strange things happen in the barber shop, like for instance, the barber cutting off his customer's head by accident. So yes, let's see what actor possibilities we have in Ruby. The first possibility that I know of is actors in Rubinius. Rubinius actually has actors in its standard library. This was developed by Mental Guy on Twitter. Mental Guy is one of the few people who've really been working on this topic for a while. If you want to follow his blog, it's very interesting. Another person who's been very active with concurrency and actors is Tony Arcieri, Bascule on Twitter. He wrote the library called RevActor. RevActor is an actor library, but it's slightly different from the other ones in the sense that it is evented. So it doesn't really use the parallel threading as we know it, but more an evented model with I/O, with network, not waiting for network connection before executing other actor code. But the one that interests me the most is Celluloid by the same guy. Celluloid is a fairly recent library. He's still working on it. I don't think it's completely stable yet, but it seems quite promising. It's modeled after the Erlang actors, of which I'll speak later. So here's some code. So this is the barber actor. I include celluloid actor module in my barber class, and this makes it an actor. And for the rest, it's a very, very simple class. So there's a haircut function, and that's about it. Then I have the barber shop. The shop keeps track of the number of customers sitting in chairs. And you have a waiting line here. And then when a customer arrives, you call new customer. And when a customer leaves, you call customer leaves. And this is the main function, calling all of them. So several customers arrive in the barber shop, one after the other. And you see this looks a lot like normal Ruby code. You wonder what's happening. In fact, this is the difference. When you call a method with an exclamation mark, you call this function, but asynchronously. So it's not executed immediately, it's just delayed. And this is also what I do when I call the barber. I send a method asynchronously. And so that's his way of modeling the message passing you have in the actor model. The problem is that running this in CRuby at this time doesn't make any sense, because with CRuby you have GGVL, and so several threads will not be executed at the same time. They will have time sharing, 10 microseconds every thread, and so using concurrency programming at this time is not possible. Although I've heard yesterday that there are plans to make parallel VMs running one next to the other, like Koichi said. But this is not the case of other Rubies. If you run celluloids in JRuby, for instance, then you will have the parallel execution. So that's what makes most sense at this time to use actor libraries. So let's look for a moment at other languages. The first you have to mention in the context of the actor model is obviously Erlang. Erlang is the first widely available commercial language centered around actors. Everything is executed basically in actors nearly. It has a very efficient VM. It's used a lot in trading, gambling, telecoms. It's basically used anywhere where you need a highly concurrent, highly parallel, fault-tolerant system. And this is basically code for the barber shop again. You'll see this is very different. One of the main differences of Erlang is that it's a purely functional language. And so you have as little side effects as possible. And a second difference is that variables are immutable in Erlang. That means you cannot change a variable. And this means you start programming with things like this. So whenever I want to change the state of the barber shop, for instance, I need to call a different function. So this is basically doing the same thing as the Ruby program was doing earlier, but with functional. So this spawns a new actor, a barber actor, and this is receiving messages. And the messages are pattern matched against tuple. So this is a message saying cutting the customer, giving the customer a haircut, or the barber sending a message saying, is there any customers, basically. This is the barber actor. It's sending a message here with an exclamation mark to the shop saying, are there any customers, please? Just to be clear, this is not great Erlang. I'm not a professional Erlang programmer, but I thought it would be interesting to show an example. And this is the main functional scenario like I showed previously, with the shop receiving several customers. And well, this is the program running. So you see the customer arrive, there's no more chairs, so Jack cannot enter the shop. So yeah, that's the example. There have been Erlang is nice and is very efficient, but one of the problems we as Ruby programmers have with Erlang is that the syntax is not very friendly. And so there have been several initiatives. The first one is Raya, by Tony Arcieri I was talking about, but development on Raya has more or less stopped. A second initiative is Elixir by Jose Valim, one of the main Rails core team members. And what he's doing is putting a nice Ruby syntax on top of the Erlang VM. I'll show an example. So we have, again, shop. I'm very sorry, there's no syntax highlighting for Elixir yet, so I'm working with this. This is basically nearly exactly the same program as the Erlang code I was showing earlier, but with some object orientation faked on top of Erlang, and then some instance variables and things like that. But it's doing the same thing. This is the barber. An interesting fact is obviously, since we're working with Erlang, we also have immutable variables. And that means that whenever we change an object, we're actually creating a new object and throwing the other one away. So this is, again, a nicer, I guess, syntax. It's an interesting project. I'm really interested to see where it's going to go. I encourage you to have a look at it and to contribute if you feel like doing that. Another language mentioned a lot in the actor space is Scala. Scala is one of the newer languages on the JVM. It has actors in its standard library as well, but what you hear talked about a lot is this framework, the framework Akka. Akka implements actors and another concurrency primitive called software transactional memory. It's apparently very efficient. I've talked to people in Sweden who are using this for a massive volume of transactions around gathering data, around advertisements on websites. And Akka is slightly friendlier than Erlang. Here's again the same code. This is the barber shop. It's object-oriented and functional. Scala is one of them languages which hasn't really decided any side, and so you can do both. So it extends actors. Then it starts a barber. And then there's a receive functions, which needs to be overridden to receive any messages you get. When the shop receives a customer, and when the barber signals he's finished cutting a customer's hair. Then there's the barber. So, yeah, again, receive function. Wake up the barber and cut the hair of a customer. This is the top of the function. You have to declare, I think, packages usually. And the messages are a kind of abstract, sealed class, which means you cannot change them. Messages between actors should be immutable. and here again is the main function, sending customers to the barbershop. And the nice thing with Scala, as with Clojure for instance, is that you can just use it with JRuby. You can just write JRuby and use all those Scala functionalities directly out of the box from JRuby. So you can write JRuby using Akka. That's perfectly possible as long as you import the right libraries in your JRuby program. I've talked about actors, but I wanted to say a few words. There's never a silver bullet. There is no perfect recipe to make fantastic concurrent programs. There's good sides to actors. They're easy to understand. You have actors sending messages to each other. Anyone can understand this. So for developers, this is very important. There's real encapsulation. Alan Kay, who was one of the fathers of object orientation, said that basically the actor model was what he had in mind when he developed object-oriented model. You can make highly decentralized program to the point that you can distribute some parts of your program to other machines if that's something you want to do. However, there's bad sides to any story you consider. The actor model is really useful when you have several chunks of code you can clearly separate and that don't share too much data. So if you have a program that really needs a sequential execution, probably the actor is not going to help. And then the fact that deadlocks and live locks are still possible. It's still possible to think of situations where one actor would wait for a message that never comes. And that's why if you want to start to work on a concurrent problem, you really need to consider several concurrency primitives. Like I said, there was software transactional memory. There's also tuple spaces. There's CSP, like you have in Go programs, you have channels. You have really several things. I encourage you to look it up. Actors model is a nice one. It's not the only one. And I want to go back to Ruby for a minute. I think it would be certainly interesting to be able to write such programs in Ruby more easily. I'm glad to hear there's work in that space with several VMs running one next to the other. You could also conceive, but I don't know how difficult that would be, that any variable you declare would be linked to one particular thread and not basically global. I don't know if that would be possible. What we certainly need, I think, what certainly would make it easier is to have concurrency primitives in our language. For instance, to have actors in our language or any of the other possibilities we have. So that's a question I want to ask you, whether this is something you consider important in Ruby or not. So that's it. Thank you very much for listening. And thank you to Makoto Inoue for translating.
はい、それでは質問を5分ぐらい受け付ける時間があります。質問のある人は手を挙げてください。はい、じゃあ真ん中の。
ありがとうございました。アクターがある言語はたくさんあると思うんですが、RAN の場合は OTP であるとか、アクター特有のデザインというのがあると思うんですね。 でそういうそのスーパーバイザーツリーワーカーはそうアーランなんていうんですかアクターのデザインに関して何か参考になるような資料とかあったらお聞きしたいんですが、アーランを見るのが一番いいんでしょうか。
There are quite a few languages out there with actors at the moment, such as Erlang, and some of them take various approaches in designing the actor system, as you mentioned in your talk. For example, Scala has the standard library version, and you've also got the alternative Akka, right?
Yes.
So, do you have any suggestions as to where to look for various approaches to designing an actor system?
You mean how to make the design irrelevant of the framework you use behind?
Not quite that, but that I guess resource for different styles of actor design. What styles of actor design exist?
Actually, I'm really interested in that. I've looked up several. I've tried to look up principles, because it's very obvious that when you want to start writing a program with actors, it's going to be different than writing a program just irrelevant of what you're using. So I agree with you that it's a very interesting problem, and I'd really like to see something about patterns with actors, because I'm sure there are patterns of communication, but I haven't found one yet.
Actually, the intent was not using actors, but implementing an actor library or an actor framework.
Oh, you mean implementing an actor framework in Ruby?
For example, Ruby or something else. Like, what kind of resources or approaches are there to implementing actors?
They all have certain things in common. First off, you have threads or processes that don't share any states. Then you have mailboxes with every actor to receive the messages. Then you have pattern matching of the messages you receive. And I think basically with that, and then the asynchronous side, basically with that you can probably develop actors.
Just let me add a few. So like Celluloid is one actor library which you can use in Ruby, C Ruby and J Ruby. The Celluloid doesn't use just a thread underneath, and you just have nice API, so like you don't have to worry about logs. So as a basic construct to implement, as long as there is something like thread, it's possible.
It uses threads. Yes.
Okay.
Yes.
はい、質問者の方に日本語にサマリーを教えてあげてください。
すいません、自分の中で納得してしまってですね、セルロイドって先ほど紹介されてたので、基本的にはスレッドを使ってて、で CRuby の場合だとスレッドってそのグローバルなんですか GLB があるんで、真にパラレル並列にはならないんですけど、JRuby の方だったらそのスレッド自身がマルチコア使えるんでできますっていうので、基本的にはスレッドを使って、あとはそれでグローバルステートをシェアしないようなイディオムを上に書き上げるっていう形だと思いますというお答えです。すいませんでした。あと訳ちょっと変なのがあったの今気がついたんでごめんなさい。以上です。
はい、それではお時間となりましたのでありがとうございました。じゃあ次関さんお願いします。はい、それからちょっとこの切り替えの時間に再度告知をして